Yes, sir, you are right.
Okay, okay. Thank you very much. Thank you. Thank you, Neeraj. Yes. So, let me continue with the topics from where we have basically the left the last topic, and the now we will take the remaining topics in the refrigeration system. Okay. So, introduction to the refrigeration cycle and the equipment. So, first part in the refrigeration cycle, that is nothing but the evaporator. So, evaporator is operating at a very low pressures, like zero point 0.5 psi, and refrigerant is sprayed into the shell, and conditioned liquid gives up the heat to the water. The refrigerant boils and passes to the absorber. Chilled water returns to the remote location. So evaporator part of the refrigerator, it is being connected with the cooling space. And for example, in the air conditioning system, in the evaporator, it will be inside the room, and the condenser will be outside of the room. So this is the normal question, that what is the position of the evaporator. You know that the liquid refrigerant, it passes through the evaporator, and passes through the evaporator. It absorbs the heat from the substance which is to be cooled. If air conditioner is there, then the space is to be cooled, then it absorb the heats from the room, and then okay, further it goes to the compressor. From compressor again, the vapors are compressed, and then its pressure is increased, and then it goes to the condenser, and from condenser again it come back to the evaporator via expansion valve or the thermostat, or the basically the capillary tube. So in case of the basically the absorption refrigeration system, the absorber is used, that is a refrigerant from the evaporator enters the absorber. The refrigerant is absorbed by the absorber, and the rate of absorption is determined by the concentration of the solution. Higher the concentration, lower chill temperature is there. Then concentrator, that is a dilute absorbent solution, flows to the concentrator. Heat sources boil the refrigerant from the absorbent, and the solution now becomes highly concentrated. So concentrated solution returns to the absorber again. Then condenser, what is the function of the condenser, which is used in the vapor absorption refrigeration cycle? It is responsible for supplying the liquid refrigerant to the evaporator. The refrigerant vapor leaves the concentrator, and this vapor is condensed back to a liquid. This liquid refrigerant returns to the evaporator. Now look at this one. The basically the evaporator. The bulb is kept over here to monitor the temperature. Okay, and this portion is fan, then the condenser, and then after the evaporator it goes to the compressor, and then condenser, filter dryer, and then again the evaporator. So, refrigeration is nothing but the removal of heat from a material or a space so that its temperature is lower than that of its surrounding. So, when the refrigerant absorbs the unwanted heat, this raises the refrigerant's temperature, that is saturation temperature, so that it changes. Okay, it changes from basically the liquid state to the vapor state, and as it evaporates, and the system then uses the condensation to release the heat and change the refrigerant back to the liquid position. So this is called as the latent heat, because phase change is being taking place over here. So this cycle is based on the physical principle that a liquid extracts heat from the surrounding area as it expands, into a gas. To accomplish this, the refrigerant is pumped through the closed loop pipe system. The closed loop pipe system stops the refrigerant from becoming contaminated and control its steam. The refrigerant will be both vapor and liquid in the loop. So the saturation temperature, it can be defined as the temperature of a liquid vapor or a solid where if any heat is added or removed, a change of state takes place. So a change of state transfers a large amount of energy, and at saturation temperature, materials are sensitive to the additions or the removal of heat. Water is an example of how saturation property of a material can transfer a large amount of heat. Refrigerants use the same principle as ice. For any given pressure, refrigerants have a saturation temperature. If the pressure is low, the saturation temperature is low, and if the pressure is high, the saturation temperature is high. So, what do you mean by the latent heat term, which is being used in the refrigeration and air conditioning system? The heat required to change the liquid to a gas, which means that here the phase change is being occurring and it is being getting converted from the liquids to the gaseous state. So therefore, the heat required to change a liquid to a gas or heat that must be removed from a gas to condense it into a liquid without any change of temperature is nothing but the latent heat. So heat is a form of energy that is transferred from one object to the another object. Heat is a form of energy transferred by difference in the temperature, and heat transfer can occur when there is a temperature difference between the two or more subject. So heat will only flow from a warm object to the colder object, and heat transfer is greatest when there is a large temperature difference between the two objects. So therefore, this is the refrigeration cycle of the demo is being shown over here. That is condenser, again the evaporator, compressor, and the throttle valve is there. Okay, so condenser, which means that the basically the compressor, condensing oil, the metering device, and the evaporator. So two different pressures are existing in the refrigeration cycle. The evaporator is nothing. Evaporator or the low pressure is the low side, and the condenser is at the high pressure or the high side. So these pressure areas are divided by the other two component. On one end is the metering device which controls the refrigerant flow, and on the other end is the compressor. So this type of compressors are being used in the refrigeration system. Okay, so compressor is the basically the heart of the refrigeration system, and compressor does not what its name is. It compresses the low pressure refrigerant. Yeah. It compresses the low pressure refrigerant vapor from the evaporator and compresses it into the high pressure vapor. The inlet up to the compressor is called as the suction line. It brings the low pressure vapor into the compressor, and after the compressor compresses the refrigerant into the high pressure vapor, and it removes it to the outlet called as the discharge line. So discharge line, you can see here the demo of the condenser. That is the discharge line leaves the compressor and the runs to the inlet of the condenser. Means after the condenser, the this refrigerant it enters into the sorry, after the compressor it enters into the condenser. Okay, because the refrigerant was compressed, it is a hot and high pressure vapor. As pressure goes up, temperature goes up, the then hot vapor enters the condenser and start to flow through the tube. So cool air is blown across the outside of the fin tubes of the condenser, usually by a fan or the water with a pump. Since the air is cooler than the refrigerant, heat jumps from the tubing to the cooler air, that is energy goes from hot to the cold, that is latent heat, and as the heat is removed from the refrigerant, it reaches its saturation temperature and start to flash, changes its states into a high pressure liquid. The high pressure liquid leaves the condenser through the liquid line and travels to the metering device, sometimes running through a filter dryer also, first to remove any dirt or foreign particle. Now, this is the demo of the metering device. Metering device regulate how much liquid refrigerant enter the evaporator. Common use metering devices are like a small thin copper tube referred to as cap tubes, thermally controller diaphragm, valves called thermal expansion valves, and single opening orifices. The metering device tries to maintain a present temperature difference or superheat between the inlet and outlet openings of the evaporator. As the devices regulate the amount of refrigerant going into the evaporator, the device lets small amount of refrigerant out into the line and loses the high pressure it has behind it. So now we have a low pressure cooler liquid refrigerant entering the evaporator coil. Okay, so the temperature goes down. Thermal expansion valve. If you look at the demo of the thermal expansion valve, the very common type of metering device is there, that is TX valve or thermostatic expansion valve. This valve has a capability of controlling the refrigerant flow. If the load on the evaporator changes, the valve can respond to the change and increase or decrease the flow accordingly. Okay, and this kind of is having the basically the sensing bulb also attached to the outlet of the evaporator, and this bulb senses the suction line temperature and sends a signal to the TXV. Okay, so normally TXVs are said to maintain 10 degrees of superheat. That means that the gas returning to the compressor is at least 10 degree away from the risk of having any liquid. The evaporator, you can see evaporator, these are the evaporator coil. The evaporator is where the heat is removed from your house, business or refrigeration box. Low pressure liquid leaves the metering device and enters the evaporator. So usually a fan will move the warm air from the conditioned space across the evaporator fin coil. The amount of heat suck is the amount of heat added to the liquid to make it saturated and change state is called as the superheat. So one way to charge a system with a refrigerant is by the superheat. Now look at the review of the refrigeration cycle. So starting at the compressor, then low pressure vapor, you can see here low pressure vapor refrigerant is compressed and discharge out of the compressor. The refrigerant at this point is a high temperature, high pressure superheated vapor. The high pressure refrigerant flows to the condenser by way of the discharge line. The condenser changes the high pressure refrigerant from a high temperature vapor to a low temperature high pressure liquid and leaves through the liquid line. The high pressure refrigerant then flows through a filter dryer to the thermal expansion valve. The thermal expansion meters the correct the amount of liquid refrigerant into the evaporator, and then the low pressure and dry vapor is then returned to the compressor in the suction line. The cycle then starts over. So this is the differences between the basically the cold refrigerated space and the that is refrigerator and heat pump is being shown over here. This is cold refrigerated space. Required input is being provided. Warm environment is there. That is refrigerator. Here warm house is there. Cold environment heat pump HP, and required input is provided. So these two bigger objectives are the purpose of the refrigerator is to removal of the heat, which is called as the cooling load from a low temperature medium, and the purpose of the heat pump is to transfer the heat to a high temperature medium, calling the heating load. So When we are interested in energy removed from a low temperature space, the device is called as the refrigerator. And when we are interested in heat energy supplied to the high temperature space, the device is called as the heat pump. So in general term, the heat pump is used to describe the cycle as the heat energy is removed from the low temperature space and rejected to the high temperature space. So look at the COP of the both the that is refrigeration cycle and the COP of the heat pump. So COP of the refrigeration is nothing but desired output divided by required input, and COP of heat pump is desired output divided by required input. So refrigeration system are also rated in terms of the tons of refrigeration. 1 ton of refrigeration is equivalent to the 12,000 BTU or 211 kilojoule per minute. Then reverse Carnot refrigerator and the heat pump. You can see here the Carnot cycle or the Carnot refrigeration. So cyclic refrigeration device operating between the two constant temperature reservoirs and the temperature entropy diagram for the working fluid when the reverse Carnot cycle is used. Recall that the Carnot cycle heat transfer takes place at a constant temperature. In our interest is the cooling load. The cycle is called the Carnot refrigerator. In our interest, the heat load, the cycle is called as the Carnot heat pump. Then COP of the that is refrigerator working on the Carnot cycle is nothing but TL divided by TH minus TL, and COP of the heat pump working on the Carnot cycle, that is TH divided by TH minus TL. So as we notice that the turbine is used for the expansion process between the high and low temperature. So while the work interactions for the cycle are not indicated on the figure, the work produced by the turbine helps supply some of the work required by the compressor for external sources. So why not to use the reverse Carnot refrigeration cycle? Easier to compress vapor only and not liquid vapor mixture. Cheaper to have irreversible expansion through an expansion valve. But what problems are basically resulting from using a turbine instead of the expansion valve? So vapor compression cycle, simple vapor compression cycle, ideal vapor compression cycle, it consists of the four process, that is 1 to 2 isentropic compression, then 2 to 3 constant pressure heat rejection in the condenser, 3 to 4 throttling in an expansion valve, and 4 to 1 constant pressure heat addition in the evaporator. So this is the pH diagram is another convenient diagram often used to illustrate the refrigeration cycle. So this is the cold refrigerated cycle space, evaporator, condenser. This is condenser. The ordinary household refrigerator is a good example of the application of this cycle. So results of the first law and second law for a steady flow. So COP of refrigerator, that is QL divided by W net minus that is H1 minus H4 divided by H2 minus H1, and COP of heat pump is H2 minus H3 divided by H2 minus H1. So what is this H2 H1? You can see here in the pressure enthalpy chart. So this is your refrigerating effect, that is H1 minus H4, and work of compression is nothing but that is 2 minus 1, that is H2 minus H1. And then we can calculate the COP of the refrigerant. So this is one example, that is refrigerant 134A is working fluid in an ideal compression cycle. The refrigerant leaves the evaporator at minus 20 degrees centigrade and has a condenser pressure of zero point 0.9 megapascal. The flow rate is also given 3 kg per minute. Find COP of refrigerator, COP of Carnot cycle for the same Tmax and Tmin and the tons of refrigeration. So from the refrigerant table, that is 134A, we have chosen these values, and we have calculated the COP of the refrigerator, which is coming out to be 3.44, and COP of the refrigerator working on a Carnot cycle, that is TL divided by TH minus TL, is coming out to be 3.97. So COP is more for Carnot cycle, but we know that Carnot cycle is not practicable, it is not practically possible. So therefore the simple vapor compression cycle which is being used. So unit of the conversion of 4.715 HP per ton of cooling. So that is also being calculated. So actual vapor compression cycle, look at the difference in the actual vapor compression cycle, because theoretical vapor compression cycle on a temperature entropy and pressure enthalpy chart we have seen, but this will be different one in the actual. Then the heat pump systems for the cooling mode, for the heating mode, look at the arrangements like a compressor, then the indoor coil, reversing valve, here the compressor, outer coil. Here the heat pump operation, that is in the cooling mode, outdoor coil, reversing coil, indoor coil, fan, expansion valve, and then the see the position of the fan and the compressor. So cascade refrigeration cycle. This part also we have covered some part in the last class. Then multi-stage compression refrigeration system, wherein you can see that in the two stage the compression process is being going on. What is the stage one? Here low pressure compressor from 1 to 2, where the refrigerant, vapor refrigerant, gas refrigerant is being compressed in the 1 to 2, and then from 1 to 2 the high pressure refrigerant is goes to the second stage in the high pressure compressor, and then it goes to the evaporator, and then through the expansion valve, flash chamber, and to the evaporator, which is connected with the cold refrigerated space. So this is the multi-staging compression system. When the basically the great amount of heat to be is to be carried out, we use the multi-stage compression system when the two compressors are being used. So a multi-purpose refrigeration system. Multi-purpose means what? Basically, the refrigerator with a single compressor can provide refrigeration at several temperatures by throttling the refrigerant in the stages. So here in this case, the process of refrigerator, the freezer, compressor, condenser, and this is the alternative path which is being also shown here. Liquefaction of gases, as you are aware that the another way of improving the performance of vapor compression refrigeration system is by using the multi-stage compression with a regenerative cooling. So the vapor compression refrigeration cycle can also be used to liquefy gases after certain the modification. Gas refrigeration system. Okay, here also COP of Carnot cycle is given by QL divided by W compressor minus W turbine. So the power cycles can be used as a refrigeration cycle by simply reversing them. Means it works on the reverse breakdown cycle, which is also known as the gas refrigeration cycle, is used to cool the aircraft and to obtain very low temperatures, cryogenic temperatures, after it is modified with the regeneration. So the work output of the turbine can be used to reduce the work input requirements to the compressor. So you can see here the gas refrigeration system. The compressor is being connected to the turbine, which is running the compressor, and then the this is the basically the heat exchanger. Here the regenerator part is there, and this warm environment and heat exchanger is there. Absorption refrigeration systems, we have studied the part of the absorption refrigeration system, and in case of the absorption refrigeration system, even we can make an use of the non-conventional energy sources like solar energy, or if the heat is readily available in the industry, then in that case that heat can be utilized by installing the absorption refrigeration system. And COP of the refrigeration system is desired output divided by required input. So it is being given by QL divided by the Q generator. Thermoelectric refrigeration system. A refrigeration effect can also be achieved without using any moving part by simply passing a small current through a closed circuit made up of two dissimilar material, and this effect is called as the Peltier effect. And also the refrigerator that works on this principle is called as the thermoelectric refrigerator. So this is the part which we have covered, and then we were supposed to deal with the this part we have already covered, turbine. Okay, the numericals or the practice-based questions on this topic. So let me check, and then we will go to the our main topic. So yes. Now we will see the some of the questions basically from the previous gate examination, and what kind of questions are there, what is the its nature, and how to attempt this question, how to solve this question. So question number the 153. Okay, that is standard vapor compression cycle is being shown. So a standard vapor compression refrigeration cycle operating with a condensing temperature of 35 degrees centigrade and an evaporating temperature of minus 10 degrees centigrade develops a 15 kilowatt of cooling, and pH diagram, okay, shows the enthalpies at various states. If the isentropic efficiency of the compressor is 0.75, the magnitude of the compressor power is correct to the two decimal you have to calculate it. So you can see here the basically the pressure enthalpy chart. On this pressure enthalpy chart, it is being plotted, that is 1 to 2, 2 to 3, 3 to 4, and temperatures are being shown. So let us say the 35 degree centigrade. Here minus 10 degree centigrade is there, low pressure line, and low temperature. Here high pressure, high temperature, like a 35 degree centigrade, and pressure enthalpy is being given. So what we need to do, that we need to calculate the basically the COP of the that is the magnitude of compressor power. So it is coming out to be 9.5 to 10.5. So it is from the refrigeration topic. Then question number 154. The ambient air is at a pressure of 100 kilopascal, the dry bulb temperature of 30 degrees centigrade, and 60% relative humidity. The saturation pressure of 30 degrees centigrade is 4.24 kilopascal. The specific humidity of the air in gram per kg of dry air is, what is the basically you have to find out. So here it comes out to be correct to the two decimal, that is 16 to 16.5. Then heat pump absorbs the 10 kilowatt of heat from outside the environment at 250 Kelvin while absorbing 50 kilowatt of work. It delivers the heat to a room that must be kept warm at 300 Kelvin. The coefficient of performance of the heat pump. So coefficient COP of the heat pump you have to calculate it. Okay. So this is another that is if the mass of moist air contained in the closed metallic vessel is heated, then the what happens to the relative humidity? Whether the relative humidity decreases, increases, specific humidity increases, or specific humidity decreases. So relative humidity it decreases. So here the refrigerator again the uses the R134A. So this is the same question which you have studied now, and its refrigerator operates on an ideal vapor compression refrigeration cycle between 0.14 megapascal to zero point 0.8 megapascal. If the mass flow rate of the refrigerant is 0.05 kg per second, the rate of heat rejection to the environment is being given by. So this is the given data which is available to you and from this data you need to calculate the rate of heat rejection. Okay, which one of the following is a CFC refrigerant? So you must know that R502 is nothing but the CFC refrigerant. Then again, this kind of tables will be given to you with respect to the saturation temperature, pressure, specific enthalpy, specific entropy, and you are expected to calculate the enthalpy of the refrigerator at isentropic compressor pressure. Then moist air at 35 degrees centigrade and 100% relative humidity is entering a psychometric device and living at 25 degrees centigrade and 100% relative humidity. The name of the device is, what is the name of the device? Because it is entering at a 35 degrees centigrade and 100% relative humidity, and psychometric living at 25 degrees centigrade and 100% relative humidity. So it is called as the dehumidifier. So this kind of questions normally will be there in the gate examination. This is the 11 gate 2011. That is, if a mass of moist air in the airtight vessel is heated to a high temperature, then what happens? So relative humidity of the air, it basically decreases. Then again, calculating the COP of the cycle. So this is being given, this data is given. You have to calculate the COP of the cycle. Okay. So Freon group of refrigerants are okay. For obtaining the high COP, the pressure range of the compressor should be high, low, or what. So likewise, you need to solve the question. The condition of the refrigerant after passing through the condenser in a vapor compression system is saturated liquid, wet vapor, or what will be the conditions? Okay, so you can see also these are the notes actually. So again, the solution and its questions are also given. Okay. So in a refrigerator, refrigerant 134 enters the compressor as superheated vapor at a rate of 0.12 kg per second with H is equal to 246.36 kilojoule per kg, and it leaves with a enthalpy of 288.53 kilojoule per kg. The isentropic enthalpy of the refrigerant leaving the compressor is that is Hs is equal to 281.16 kilojoule per kg. The refrigerant is cooled in the condenser and it leaves the condenser in subcooled region with H is equal to 84.98 kilojoule per kg. It is then throttled to 0.15 megapascal. The isentropic efficiency of a compressor and COP of the refrigerator are. So you have to calculate the isentropic efficiency and the basically the So these are the various question. Um, just so in the online methodologies also, you will find some numericals which is based on the simple vapor compression cycle, and you can attempt the similar type of question. Okay. Then again, this question is given, that is a standard vapor compression refrigeration cycle operating between this temperature. So gate 2018. Now again the detailed solution is being provided. Look at this one. The pressure enthalpy chart which is being given, 1 to 2 compression, 4 to 1 evaporation, and then from this one. So how the students they commit the mistake by multiplying the efficiency rather than dividing it. Okay, so this kind of more vapor compression cycle questions. So like a household refrigerator. Household refrigerator, it operates on which kind of cycle? Whether it is a reverse Carnot cycle, cascade refrigeration system, vapor absorption cycle, or vapor compression cycle. So it operates on the vapor compression cycle. So what is the explanation for this one? The vapor compression cycle is a process used to extract the heat from a box or a room that underlies most refrigeration air conditioning technique, and it is consisting of the four separate stages, that is compression 1 to 2, condensation 2 to 3, expansion 3 to 4, and evaporation 4 to 1. So and the domestic refrigerator, the purpose of extract basic vapor compression, TS, and the pressure diagram. So most of you will get confused that whether it works on vapor compression or vapor absorption. Also, here is a simple trick to remember. You might have noticed that the compressor installed at the back of our domestic refrigerator, that is, it's because the cycle on which it works is a vapor compression. So which of the following is a true for a refrigeration cycle? Whether it operates on the radiation, it is based on a combustion cycle, it uses the cryogenic fuel, work is done on working fluid by compressing it. So the option 4 is correct, that is work is done on the working fluid by compressing it. So the refrigeration, the purpose of refrigeration is to cool the space, objects, and the material, and to maintain them at temperature. So you know that refrigeration cycle, the refrigerant must alternate between the low temperature and high temperature, and this is the vapor compression cycle. The cooling effect, subcooling effect is also being shown, that due to the in actual refrigeration cycle, the temperature of the heat sink will be several degrees lower than the condensing temperature to facilitate the heat transfer. Hence, it is possible to cool the refrigerant liquid in the condenser to few degrees lower than the condensing temperature by adding an extra heat area for the heat transfer. So, in such case, the exit condition of the condenser will be in the subcooled liquid region. Hence, this process is known as the subcooling. Here, you can see that subcooling, which increases the refrigerating effect. So subcooling is beneficial as it increases the refrigerant effect by reducing the throttling loss at no additional specific work input. Also, subcooling ensures that only liquid enters the throttling device, leading to its efficient operation. So what do you mean by the process of superheating? Here in this case, on the pressure enthalpy chart, you can see that the end that is instead of this 1 to 2, this particularly 1 dash 2 dash is being shown, the process which is followed, and from 4 to instead of 4 to 1, there is a in the evaporator 4 is to 4 dash 1 dash, which means that the that is refrigerant is superheated. The temperature of the heat source will be few degrees higher than the evaporator temperature. Hence, the vapor at the exit of the evaporator can be superheated by few degrees. The superheating of refrigerant takes place due to heat transfer with a refrigerated space, and then it is called as the useful superheating as it increases the refrigerant effect. So, on the other hand, it is possible for the refrigerant vapor to become superheated by exchanging heat with the surrounding as it flows through the connecting pipelines such as super, and such type of superheating is called as the useless superheating as it does not increase the refrigeration effect. So this is your useful superheating, which increases the COP. So when water lithium bromide is used in a vapor compression refrigeration system, then what is true? Okay, they together act as a refrigerant. Water is a refrigerant. Lithium bromide is a refrigerant, or none of these. So water is a refrigerant. Look at the concept of the basically the vapor absorption system. So in the vapor absorption system, the water is used as the refrigerant, while lithium bromide is used as the absorbent. Okay, so here condenser, expansion device, evaporator. Here you can see here the generator, absorber. This is the difference between the vapor compression cycle, simple vapor compression cycle, and vapor absorption refrigeration system. Here evaporator, compressor, condenser, expansion. But here in this case, the evaporator, absorber, then the generator, expansion device is also there, then condenser, expansion device, and again goes to the evaporator. So basics of vapor absorption system, that is it employs the two fluids, the absorbate refrigerant and absorbent. The most common fluid are water ammonia as the refrigerant and lithium bromide water as a absorbent. So this will be the case. So this is again liquid bromide is used as an absorbent in which kind of system? So just now we have studied that vapor compression refrigeration system, vapor absorption system, steam jet refrigeration, and electrolysis refrigeration. So it is used in the vapor absorption system. This is again the question like in vapor absorption refrigeration system, heat is rejected in condenser only, generator only, absorber, condenser, and absorber. So it is rejected in the condenser and the absorber. Then which of the following components of vapor absorption refrigeration system has same pressure level, neglecting the pipe process? So it is evaporator and the absorber. So again the explanation is being shown. Okay. So look at the basically the questions over here. That is, you have to pick up the wrong statement out of the this one. Refrigerant should have. what it should have, wrong statement, that is low specific heat of liquid to means high boiling point, high latent heat of vaporization, higher critical temperature, low specific volume of vapor. So it should have the basically the high boiling point. हॅलो. हां. हां, गुड इव्हनिंग. क्लास चालू आहे. मी 10 मिनिटांनी करतो तुला कॉल. हां. A standard ice point temperature corresponds to the temperature of water at 0 degree centigrade, ice at 4 degree centigrade. So, E mixture of ice and water under the equation. Then vapor compression refrigeration is somewhat like a which cycle? Vapor compression refrigeration system is like a which type of cycle basically. So whether it is a Carnot cycle, Rankine cycle, reverse Carnot cycle, reverse Rankine cycle, or none of the above. So it is Carnot cycle, Rankine cycle, reverse Carnot cycle, reverse Rankine cycle. It is none of the above. Which of the following cycles uses air as a refrigerant? So you know that Ericsson cycle, which is Bell-Coleman cycle, it uses the air as a refrigerant. Ammonia absorption diffusion cycle requires very little work input, maximum work input, nearly same work input as say, vapor compression cycle. So it requires very little work input. An important characteristics of a absorption system of refrigerator is, so absorption refrigeration system, it is quite in operation. Okay. The relative coefficient of performance is the nothing but the actual COP divided by the theoretical COP. Theoretical COP divided by actual COP. So you have to select the correct answer, that is actual COP divided by theoretical COP. So in a vapor compression cycle, the condition of refrigerant is very wet vapor. So wet vapors are there when basically before entering the compressor. In a vapor compression cycle, the condition of refrigerant is high pressure saturated liquid, that is before entering the expansion one. Okay. The moisture in a refrigerant is removed by what dryer? It is being removed by the dryer. Critical pressure of a liquid is the pressure above which liquid will remain liquid. That is the critical pressure. Critical temperature is the temperature above which a gas will never liquefy. Means it will not change its phase. The refrigerant for a refrigerator should have the high latent heat. Now, rating of a domestic refrigerator is of the order of zero point 0.1 ton, 5 tons, 10 tons, 40 tons, 100 tons. So normally 5 tons, 10 tons, 40 tons, and the 100 tons, these kind of systems are not used in the domestic refrigerator. It is being used in the industrial refrigeration processes. So therefore, the correct answer, the closer answer is zero point 0.1 ton. So COP of a domestic refrigerator is less than 1, is more than 1, or is equal to 1. So it is more than 1. The domestic refrigerator uses following types of compressor, that is piston type reciprocating compressor. So air refrigeration operates on which cycle? Air refrigeration system operates on the Breton cycle. Air refrigeration cycle is used in which application? So whether it is domestic refrigerator, commercial refrigerator, air conditioning, gas liquefaction, so it is used in the gas liquefaction. In a vapor compression cycle, the refrigerant immediately after expansion valve is goes to the wet vapor. So, in the similar fashion, you need to solve many some questions and practice the questions so that you can solve the on the this topic of refresher air conditioning. So, for a better COP of the refrigerator, the pressure range corresponding to the temperature in the evaporator and condenser, it must be small. The bank of tubes at the back of the domestic refrigerator are, what is the bank of the tube? We have discussed that the part of the condenser is being located outside of the room. So this bank of the tube are nothing but the condenser tube, because capillary tube, throttling device, evaporator tubes are in the inside the room. High temperature in vapor compression cycle occurs at the high temperature at the basically the compressor discharge. So absorption system normally uses the following refrigerant. So it uses the ammonia. So what is the purpose of the subcooling of the refrigerator? So ensure that the liquid, only liquid and not the vapors enter the expansion wall or throttling wall. So value of the COP in vapor compression cycle is usually always more than unity. So okay, these are based on the basically the gas refrigeration. So ideal gas refrigeration cycle is same as that of the basically the reverse Breton cycle. Gas refrigeration cycle MCQ. So concept is being also in explained. So in the context of an aircraft refrigeration cycle, what is the temperature of the air at the exit of the cooling turbine in the absence of moisture condenser? So it is dry air rated temperature. So this is the which refrigeration system is driven by a low grade energy. Steam jet refrigeration system is powered by the low jet energy. Okay. So these are the some of the solved examples in the gate examinations. So what you need to do, there are certain online sites are also being available, wherein you can look for the various solved numericals and try to focus on these numericals, practice it and prepare for this one. So normally in the topic of refrigeration and air conditioning, there will be numericals which is based on the particular topic. So you need to no need to carry the psychometric chart or the refrigeration tables, because refrigeration tables will be given to you and all values will be given to you. You need not have to carry your psychometric chart with you. Okay, refrigeration tables with you. All the values will be given and you need to work on that particular problem. So today we will stop here with these applications of the refrigeration system and practice of the refrigeration system. So in the next class, we may start with the basically either with the CPM per topic is being remaining. Similarly, air conditioning topic is also being remaining. So CPM and PERT or the project management techniques like a transportation linear simplex model. These are the time consuming techniques. So I think we should start this topic in the next class. So thank you very much. Wish you all the best. See you tomorrow.
Okay, sir. Thank you. Thank you so much.
Okay. Thank you.